Ever wondered how your phone just gets you? How you can just talk to your smart speaker and it plays your favorite song, sets a timer, or tells you a joke? It feels like magic, right? Well, today we're pulling back the curtain on this incredible technology. We're going to dive deep into how speech recognition actually works. If you're curious about the tech that's changing our world, make sure to hit that subscribe button and ring the notification bell so you don't miss out on our future videos. All right, let's get into it. At its core, speech recognition is the process of converting spoken language into written text. Think of it as a superpowered translator. But instead of translating from one language to another, it's translating sound waves into words. So, how does it start? It all begins with your voice. When you speak, you create vibrations in the air. These are sound waves. Your device's microphone acts like an ear, capturing these vibrations and converting them into a digital signal. This process is called analog to digital conversion. Imagine your voice being turned into a stream of numbers that a computer can understand. But this digital signal is just a messy jumble of data. It's noisy, it has pauses, and everyone's voice is different. So, the next step is pre-processing. The system cleans up the signal, removing background noise like a car horn or a fan. It also breaks the continuous stream of sound into smaller chunks, typically hundreds or thousands of a second long. These chunks are called frames. This is crucial because it makes the massive amount of audio data manageable. Now comes the really clever part, feature extraction. The system analyzes each of these tiny frames to identify its unique characteristics. What are the most important frequencies in this tiny slice of sound? This is kind of like identifying the key ingredients in a recipe. The result is a compact digital representation of your speech, highlighting the most important parts and ignoring the rest. This creates a sort of acoustic fingerprint for each sound. With these fingerprints, the system is ready to guess what you said. This is where the acoustic model comes in. This model has been trained on thousands and thousands of hours of recorded speech from countless different people. It's like a massive library that maps these acoustic fingerprints to the smallest units of sound in a language called phonemes. In English, we have about 44 phonemes. Sounds like K, shoe, or the A in cat. The acoustic model listens to your speeches, fingerprints, and calculates the probability of which phonemes you just pronounced. It's essentially saying, based on this sound, there's a 90% chance it's a T sound and a 10% chance it's a D sound. But a string of phonemes isn't a sentence. Kati means nothing on its own. We need to turn these sounds into actual words. This is the job of the language model, sometimes called a lexicon or dictionary. The language model contains a huge vocabulary of words, and more importantly, it understands grammar and the probability of words appearing together. It knows that "how are you" is a much more likely phrase than "how are shoe." So, the system combines the acoustic model's best guesses with the language model's knowledge. It looks at all the possible combinations of words that could match the phoneme sequence. For example, did you say recognize speech or recognize speech? Acoustically, they can sound very similar. The language model steps in and says, well, recognize speech is a much more common and logical phrase in this context. It calculates the most probable sequence of words, creating the final text output. This entire process, from sound wave to text, happens in the blink of an eye. Modern systems use advanced machine learning, specifically deep neural networks, which are inspired by the human brain. These networks are incredibly good at finding patterns in vast amounts of data, making speech recognition more accurate than ever before. They learn from every interaction, constantly improving their ability to understand different accents, speaking styles, and even slang. And that's the journey of your voice, from a simple vibration in the air to a command understood by a machine. It's a symphony of physics, computer science, and linguistics working together seamlessly. So next time you ask your device for the weather, take a moment to appreciate the incredible journey your words just took. I hope that demystified some of the magic for you. It's a fascinating field that's only getting better. What do you think is the coolest application of speech recognition? Let me know down in the comments. Thanks so much for watching, and if you enjoyed this video and learned something new, please give it a thumbs up, subscribe to the channel, and hit that notification bell. We'll see you in the next one.